we're doing question 1 of the exam, and this is actually from the tutorial 7A.32 question 2. We're only going to do the first section, which is find the voltage across V3 with nodal. So the first thing we're going to do is write our node equations, and I'm just going to write them all without values, first of all. V2 minus V1.
Just make it easy, can you put which node's what?
Oh yeah, sorry.
That's right.
V1, V2, V3, and that's a short circuit, so that's also V1. V3 minus V1. Equals 0. Okay, so now that we've done that, what I'm going to do is I'm going to combine those, the V1s, combine the like terms. So I'm going to take V1, I'm going to take the R out, and then that just becomes J C minus V2, 1 on R2, minus V3, J omega C is equal to IS. Same thing for the next one, minus V1, 1 on R2. Sorry, let's label these R1, R2, R3, R4. That's C1 and that's L1. So, sorry, this is going to change that to R3 because we've got R3 here, not R4. Okay, so plus V2. 1 on R2. This becomes 1 on JL. That's right. That's V2, and then the last one is 1 on R3 minus V3. 1 on R3 is equal to 0. Next section, which is 1 V1, J omega C, minus V2, 1 on R3, plus V3, J omega C, plus 1 on R3, plus 1 on R4 is equal to 0. Okie dokie. So we're going to put this into our matrix. So we're going to do that up here. Becomes IS 0 and 0. So our IS we can replace now, and that's going to be 10 angle 30. So we'll put that in here, 10 angle 30, and now it's just a matter of filling these in. So we're going to take these ones here, your omega here is 10 to the 4, because you've got 10 to the 4 here. So that becomes 4J with the capacitor at 400 microfarads. And this is just 1 plus 1, so we're going to get 2 plus 4J here. Here we've just got 1 on 1, negative at the front, gives us negative 1. And here we've got J omega C again, which gives us 4J. We've got the negative out the front, so negative 4J. Okay, next step, 1 on 1, negative 1. Next part gives us 1 plus 1, which is 2. And that becomes negative, because it's 1 on J. And it gives us a quarter J. And this last bit here gives us negative 1. Alright, next line, that gives us negative 4J. 1 on 1 is 1 minus, and 1 plus 1 and a plus a half, sorry, gives us 1 and a half plus 4J. Awesome. So that's that bit. Now what we're going to have to do is Kramer's rule. I'll do that over here. So Kramer's rule states this one is plus, minus, plus. So we do this value here. Actually, let me get a different colour. This value here times by the determinant of this value here. The determinant of that matrix there, sorry. So you remember the determinant is that, those two numbers times, minus those two numbers times. And then you do that, so that becomes the plus of that value. Then you do the same thing here. Take that out. So Kramer's rule again, which gives us minus the determinant of the matrix without the center section. So just that matrix there. So you do minus 1 times whatever here, and then minus that, times by negative 1, and then you minus all that. Last section is, last one, sorry, it's positive, so you do this times by the determinant here. Alright, so we're going to go ahead and do that. The first determinant is negative 24.5 plus 27.25. And now if you've got a calculator that does complex numbers, you can do all this by just typing it into your calculator. Make sure you've got plenty of brackets in the appropriate places. And minus, so that's that middle section now. So this is the determinant or the value for this value here. So we do the next one, which is going to give us 1.5 plus 8. So we'll stick with name J plus 32 minus 8J. Sum those, which is going to give you the determinant of 6 plus 11.25J. Now the next step is we want to find V3, because that's what the question asked us for. So we're going to sub these values into this first section here. And
Just grab them in.
Yeah? Wait a minute. So, it's been here. Now once again, if you've got a calculator that can do imaginary numbers or complex numbers, you can just type all this in and it will give it to you. Make sure you've got plenty of brackets again. So your first section is going to be the matrix of that, which is going to give you 0 because you've got 0 at the bottom. So the first one's 0, and then it's minus, that's going to give you 0 again because you've got 2 zeros here. 0. So the last one is going to be the matrix there, which gives us you sum all that together, it will give you the matrix of determinant of V3 is equal to negative 22.67 plus 79.28 pi. Now the next step is to divide that by this one up here, which will give you 4.64 plus 4.49j. Take that into rectangular form, gives us 6.467, angle 44.03 degrees.
Which is V3.
Which is V3, and your answer.
Are all the answers in cos form?
In cos form, is it? Okay, so it gives us 6.467 cos 10 to the 4 plus 44.03.
10 to the 4t.
10 to the 4t, thanks. And there's your answer. Enjoy your 5 marks.